going? Woohoo! Yeah, it's another math video, my friends. Another Eureka math video for those people who like Engage New York. And look at what we have is this our feature animal of the day? Oh, really? Yes. Okay, so now all my little jungle friends here are getting little names for themselves, Leonardo? Yes. Okay, Leonardo. Yes, I will refer to you as Leonardo. Oh my goodness. They're really becoming lifelike, aren't they? Well, Leonardo, you're gonna you're gonna get small. Really small. Now, we won't make you that small. Yes, I will. Ah! Oh my goodness, you're just a dot. No, I'm just kidding. I'll make you a little bit bigger than that. There you go. We'll leave you there at that size. Hey, my friends. Well, we are here for another video, and it's the learning target. Let's look at what we're going to be focusing on. Learning target says we're going to solve and create fraction word problems involving addition, subtraction, and multiplication. Oh my goodness. Yes, my friends, I'm here to tell you this video is going to be intense. So really, I know I say buckle up because the ride could be bumpy. This ride's going to be so bumpy you might just bump right out of the car. So, hang on tight. Let's go ahead and look at problem 1. It says here, a baseball team played 32 games and lost 8. Katie was the catcher in 5/8 of the winning games and 1/4 of the losing games. Okay, we have two questions here. First one says, what fraction of the games did the team win? And B says, in how many games did Katie play catcher? Okay, I'd say this is a pretty challenging problem. So let's go ahead and just kind of take this step by step, and we're going to kind of think about our strategy of read, draw, and write. And that helps me kind of focus along here because first thing is about reading and understanding the problem. Couple facts I have to kind of keep in mind of what I know. I know that there were 32 games, so I have a whole amount. They played 32 games. And the team itself lost 8. So let's go ahead and represent this with a tape diagram. Okay, we know that we have 32 games that were played. And we know that 8 were lost. Well, if I wanted to show this as a tape diagram, I could take a portion of this, and since 8 is only a part of, I could show my lost, and that's going to be 8 games that were lost. Now when I come to how many games were won by the team, well, I don't know. But by looking at my tape diagram, and not that we needed to do one, we can write that equation. Well, 32 minus 8 then must equal the number that were won, and that's 24. But the question that's being asked of us is what fraction of the games did the team win? So we're looking at a fraction. Well, I can almost think of that as a fraction then. Now remember, when we look at fractions, we're always looking parts of the whole and how that whole is divided. In this problem, 32 is our whole. It's kind of like our whole part. And so how many games of 32 were won? So that's what they want to know, the number of games. The fraction of the games a team won. So I could put 24 over 32. That's my answer. That's the fraction. What fraction of the games did the team win? Well, they won 24 out of 32. However, this isn't in simplest form, and this fraction we wouldn't usually leave in this form. It's not a simple enough fraction for us to sometimes conceptualize. Okay, I definitely see an 8 I can divide out, giving me 3/4. So 3/4 is a more recognizable and benchmark fraction. So now we have 3/4. Okay, so we have 3/4 of the games were won. So let's write that. We did the read, draw, and the drawing was our tape diagram, and now we have to do the write portion. So I'm going to write the team won 3/4 of the games. Now, in how many games did Katie play catcher? Now we're going to have to look at this information that Katie was the catcher in 5/8 of the winning games. So let's take a look at that. So the number of games that she was involved in, so we'll put 1. So she was in 5/8 of, and remember our number was 24. That was how many games there were that the team won. She was in 5/8 of that amount. This is saying equal, well, this is just 5 times 24 over 8. And if you look over here, what we can do when we multiply fractions, we just multiply the numerators and then multiply the denominators. And I can put 24 over 1 because 24 divided by 1 is 24. So it doesn't change the value. And then now I have 5 times 24 over 8. Now you can go ahead and multiply the 5 times 24 and then divide by 8. However, 5 times 24 is going to give us a really large number. Rather than getting that really large number and having to divide out common factors that we see, we could actually do that now. I am observing there's an 8 and a 24, and they have a common factor of 8. So what I'm allowed to do is I'm allowed to divide out an 8. Well, 8 divided by 8 equals 1. And if I divide the 8 from the 24, 24 divided by 8 equals 3. Well, this is great because now I end up with 1 as a denominator. Makes this really easy just to take 5 times 3, which is equal to 15. So now that we have 15, we know that she was in 15 of the winning games. But we're not done because she also was in some of the games that they lost. And they lost, remember we have that fraction now. So now we're going to take that 1/4 of 8. That's going to equal our 1. We're going to end up with 1 times 8 above and then over 4. And again, this can be written as 8 over 1. Now we can divide out our common factors. 4 divided by 4 is 1. It also has a common factor. 8 has a common factor of 4. So if we divide 8 divided by 4, we end up with 2, giving our answer of 2. So Katie was in 15 winning games. She was in 2 of the losing games. So this question asks us, how many games did she play catcher? Well, it's going to be the 15 games that she was playing catcher that she won, plus the 2 games that she was in where she was playing catcher that they lost, meaning that she was in 17 games altogether. Okay, so let me go ahead and write that as a statement. Katie played catcher for 17 games. But this isn't the only way to solve it. I mean, I can see another way that this problem could be solved. Let's take a look at that. So another way that we could look at this, again, we have our tape diagram. We could still show our total of 32 total games. Again, this is just the games. We can think there's a portion of them that were lost, and that was fewer of them, and then a portion that were won. Okay. Now we already learned in the word problem that 8 of those games were lost. So we could actually look at this based on the number of games lost rather than won, just doing the reverse. So we had 8 games that the team lost, and that was out of 32 games. This number, if we were to put it in simplest form, we can see that we can divide out an 8 on both the numerator and denominator, giving us 1/4. Well, if we know that the team lost 1/4 of their games, that means then, so the games won then would be 3/4. Another way that we could have solved that first part on A. So the team won 3/4 of the games. Now for part B, we could kind of think of it as this. We have 24 games that the team won. We determined that, right, because we knew the 32 games they played minus the 8 that they lost left us with 24. So what we could do is we could take that 24 then, we could actually split our tape diagram into 8 equal parts, since she won 5/8 of those games that the team won, where she was playing catcher. So in this case, we could say that the 8 units here that we have is equal to 24. 1 unit then would be equal to, well, think about it. If we have 8 equal units and we have 24, 24 divided by 8 would mean that we would have 3. And we're trying to figure out what 5/8 is. So we get 1, 2, 3, 4, 5. So this is the amount of games that we don't know Katie played in as catcher. So now we have each unit is 3. By doing that little division, we can figure out that she was indeed 5 units, or 5 times 3 is going to be equal to 15. So she played in 15 games of the 24 that the team won, because we determined she played in 5/8 of the winning games. So we just took the winning games of 24 and we made 8 equal units here so that we could determine what 5 would be, and then 5/8 of that 24. And this is just showing a tape diagram to show that. Now if we went to the lost, so let's just say that this one here is of the 1, and down here this is the ones that she played catcher but where they lost. Well, what was the total for the lost? The number of games the team played that they lost for 8 games. Okay, she played catcher in 1/4 of those games. I can show this is my 1/4. This is what we would need to figure out. So let's come back over here and state some facts. First thing, I divided up into 4 equal units because I needed quarters for that 1/4 Katie had played in as catcher. So 4 units is going to be equal to 8. 8 is this whole part, and so there's 4 units inside that 8. So that would mean then each unit that we have down below would be 2. 2, 4, 6, 8. Maybe you see that already. That means each unit or each quarter case is going to equal 2 games. So Katie played, and she played 15 games that they won, and she played in 2 games that they lost. So now we have 15 plus 2, so the number of games, which is going to equal 17 games. Okay? It says in Mrs. Elliott's garden, 1/8 of the flowers are red, 1/4 of them are purple, and 1/5 of the remaining flowers are pink. If there are 128 flowers, how many flowers are pink? So I think the best way I would like to start this problem is maybe getting that tape diagram. Let's do that. So here I have my tape diagram, and so I'm looking at this, and the first thing I'm thinking to myself is the whole. And it looks like the whole we already determined is going to be 128. So I have 128 flowers. Okay, now this is where I kind of come into the portion of flowers. I have fractions. One thing I could think of it is this way. Red is 1/8 of the flowers, and that would mean 1/8 of the total of 128. Well, I could go ahead and show this. 128, if I were to multiply across, would be 1 times 128, because remember, we can show this as being over 1, and then that means that's going to all be over 8. Like we did in the previous problem, we went ahead and we divided out common factors. Well, common factor of 128 and 8, you may not see this. 8, times 16 is 128. So let me divide out an 8. That's going to leave 1. I'll divide out an 8 here, and that's going to leave me 16. Hence, therefore, my number is just going to be 16. Well, that means 16, so 16 of the flowers are going to be red. So I'm going to go ahead and show this on my tape diagram. These aren't drawn exactly, but just kind of showing you the little fraction here. So I have 16 that are red. So now I come to purple. It says that 1/4 of the flowers are purple. Again, our whole part is the 128. So now I can go ahead and multiply across again. 1 times 128 divided by 4. Now this one here, I'm not seeing, let's see, 4 would go into 12 3 times exactly, and then 4 would go into 8 2 times. I bet that's 32. So I divide this 4 by 4 gives me 1. If I divide that, I'm going to get 32. 1/4 is double the size of 1/8. So 16, you can see with 32, it's double 2. So that seems like a logical. Maybe this little thing here needs to be about double. And now I come to the biggest section, which is all the ones that are remaining, right? The ones that are remaining are supposed to be pink. But we don't know how many of those are. We just know the remaining flowers are pink. Well, I suppose the easiest way to figure this out at this point, maybe just take our 128, right? We can subtract our 16, which were the red ones, subtract our purple ones, which were 32, and that's going to give us a quantity. And if we were to take 16 and 32, combine those, I see 48. So if I were to just take 128 minus 48, you can see that our answer is going to be 80. So how many flowers are pink? That's the question that it's asking us. Actually, no, it does not say that. It says 1/5 of the remaining flowers are pink. Not that all the remaining flowers are pink. So now I have the remaining flowers, which is 80. 1/5 of those are pink. So now we can go ahead and do our pink. 1/5 of 80 is going to be equal to 1 times 80 over 5. So 80 divided by 5. Did we do that one before? 16. I think that's right. 16 times 5. 3. Yes, it is. That's my 3, just so you know. 80. So I'm going to divide a factor of 5 out and get 1. I'm going to divide a factor out of 80 of 5. I'm going to get 16. So I'm going to get 16. So 16 of the flowers are pink. Looking at this problem, I can see that there's other ways that this could have been solved. Let's look at another way. So look at this tape diagram here. We have our 128. What we could do is, since 1/8 and 1/4 both have a common denominator of 8, is we could actually divide our 128 flowers that we have here in this tape diagram and divide it into eighths. 1/8 of the flowers here, we could write that these are red, okay? And then because the purple flowers are 1/4, we talked about it being double. That's like two of these together. 1/8 plus 1/8. Yeah, it's 2/8, and 2/8 is equal to 1/4. So if I have 8 units, then is going to be equal to the 128. So 1 unit then would be equal to 128 divided by 8. And 128 divided by 8, we've already established this one here, but you see that goes in there one time. We get 4 left over, so we end up with 16. So 1 unit is going to be equal to 16. Each unit here, we could actually write 16. What we can do is, since we know that each unit here is 16, then what would 5 units here be equal to? And those 5 units times 16, which we've done before, is equal to 80. So we could say that those 5 units out of the 8 units altogether, remember we made 8 units, is equal to 80. Well, let's go ahead and just draw and just show on another tape diagram right down below here. Here are my 5 units. That's my 80. And what we're trying to find out is 1/5 of the remaining flowers, which was 80. Well, in this case then, that means that on this tape diagram down below here, since we have 5 equal units here, that's going to be equal to 80, okay? Just by doing this other tape diagram, I had these in eighths, but now I'm taking these pieces here, and I'm saying that that quantity here is 5. Well, then that means 1 unit then is going to be equal to 80 divided by 5. And 80 divided by 5, we determined before, was, I believe it was 16. Goes in there one time. Yes, it was. So now we have 16. So 1 unit is equal to 16. And sure enough, that means 16 flowers are pink. There we go. That's the 80 that were remaining. And then we took that fraction, which was 1/5. So we divided that 80 into fifths. So then we could say that this was this 1 unit, we did know what it was. And now we turned out that that's going to be 16. Now yet another method that we could kind of think of, but one thing we do know that the 1/8 up above plus the 1/4, these are the fraction of flowers, is equal to, if we were to add these together, 1/8 plus, and we know that 1/4 is equal to 2/8, is going to be equal to 3/8. Now what's interesting here is what we could do instead is we could just say we've added the red flowers and the purple flowers together. That gives us 3/8. That means those together is going to be 3/8 of 128 flowers. Okay, and we can go ahead and just multiply across. 3 times 128. We divide that by 8. Okay, again we have that common factor. Remember it was 16. If we divide 128 by 8, we will get 16. 8 divided by 8 is equal to 1. So now we end up with 3 times 16. That's over 1. So that's going to just equal 48. All right, let's continue down. So then 128 flowers total minus the 48 flowers, which was the red and the purple, is going to equal 80. Now, this means that the pink, we have to be careful, and I think I was even thinking in these terms when I was solving the problem myself. It's 1/5 of the remaining flowers, not 1/5 of the total that are pink. Okay, it's 1/5 of the remaining. The 80 represents what's remaining, so it's 1/5 of 80, not of the total 128. Okay, be easy to be confused on that. Now I have my 1 times 80 over 5. I can take out my common factor of 5. If I divide 5 by 5, it's 1. Divide this by 5, I'm going to get 16. 16 seems to be a very popular number. And there you go. 16 of the flowers are pink. Now so far this strategy seems to make the most sense to me. This is the way that I would solve the problem, because the problem initially as fractions of a whole, it's so much easier to determine that fraction with the pink, so to kind of work that way. There's yet another way. Now we could think of it this way. If we had our tape diagram and we want to show our whole, and then let's go ahead and put that into 8 equal units. That means again 8 units is going to be equal to 128. Now 1 unit is equal to 128 divided by 8, and we already know that's 16. So 1 unit is equal to 16. Now thinking about fractions of what we had before, 1/8 of the flowers are red. There you go. Now 1/4 of the flowers are purple, so that means it's going to occupy 2 of those units. Okay, so if each unit is 16 and it said 1/5 of the rest. Well, here's the rest right here, and it's 1/5. That's this one right here. We don't know what it was, but now we know that's 1 unit. That's pink, 16, because it's 1/5 of the rest here. Now it happens to be, you might be thinking to yourself, Mr. Warr, I'm really confused. I thought you said that the red was 1/8. It is 1/8 of the total of all the flowers, 128. Happens to be 16. However, the 16 happens to be 1/5 of 80. And that's what we were figuring out. So 1/5 of the rest, which we know is 80, is going to be equal to 16. So 16 flowers are pink. Moving on to problem number 3. Oh, really? It's overcast now, so you took the shades off? Yeah. You did it with your paws? Okay. Now, see, now I've heard it all. Okay. Problem 3 says Lillian and Darlene plan to get their homework finished within 1 hour. Darlene completes her math homework in 3/5 hour. Lillian completes her math homework with 5/6 hour remaining. Who completes her homework faster and by how many minutes? Oh, we have a bonus? Give the answer as a fraction of an hour. So look, I'm going to give my notes down. So I'm going to use, so Darlene, it says that she can complete her homework in 3/5 of an hour. Well, that's 3/5 of 60, which means times 60, because that's of the hour. So it's 3 times 60 over 5. Do I have some common factors that I can divide out? I do. 5. If I divide 5 by 5, I get 1. If I also divide 60 divided by 5, I'm going to get 12. So now I have 12 times 3, which is 36, and this is going to be 36 minutes. Now the reason why it's 36 minutes is because we multiplied by 60 and there were 60 minutes in 1 hour, so we converted that. Lillian says that she completed her homework in 5/6 of an hour, but remaining. Key point to that's what's remaining. Well, then that would mean, if that's what's remaining, that means that there's 1/6 left of that hour, 1/6 of an hour. So it actually means that she completed it in 1/6 of an hour. Well, now we'll follow our same pattern. 1/6 of an hour. So we're going to take 1/6. We are going to multiply that by 60, which is going to be equal to 60 over 6. All I did was did my 1 times 60. Now do I have common factors? I do. But it's also just a division problem, 60 times 6. The common factor, of course, is being 6. So that's going to leave me with 10. 10 minutes. So we can take our 36 minutes, which was Darlene, subtract that by the 10 minutes, because I can abbreviate that, it's going to be equal to 26 minutes. So Lillian did complete the homework faster, and she did it in 26 minutes faster. Now they had a bonus. What was the bonus? The bonus to give the answer as a fraction of an hour. So the bonus was give it as a fraction of an hour. I would do it this way. Since there's 26 minutes, it's 26 minutes faster. That's like saying 26 minutes over 60 minutes. And now we're able to divide out common factors. Here I can see a 2. Let's just divide out a 2. That's going to give that 13 because that's double. Divide that by 2 is going to give that 30. 13 is a prime number. That's where it ends. So we can say that it's 13/30 of an hour. Of course, an hour faster. There's yet probably another way. Yeah, the old tape diagram way. Problem 4. It says now we're going to create and solve a story problem about a baker and some flour whose solution is given by the expression 1/4 times the sum of 3 plus 5. We have two things going on. We have the 1/4 and then we have that sum 3 plus 5. Kind of think of this in different ways. These numbers could like represent cups. Cups are a unit of measure, so by using this expression, we could think of these numbers and just use them as cups or teaspoons or whatever. So one thing I think I would be thinking to myself here is I could think that maybe the baker combined 3 cups of sugar and 5 cups of flour together. Okay, since this is a sum. Thinking of 3 plus 5 would be, maybe this could be the 3 cups of sugar. There is obviously many ways that you could represent this problem, and this could be your 5 cups of flour. Okay, it doesn't say, this is about a baker, so whose solution is given by that, but we have to come up with something else. When you're baking, you need sugar as well. Okay, and then these again could be mixed together in a bowl. Now the quarter, where that could maybe come in, the quarter could come in by thinking of, maybe the baker used a quarter of the mixture here to bake cookies. And so then our question would be, how many cups of the mixture did he use? Because we're taking 1/4 of that amount. Maybe he just made extra, whatever. Maybe he's not going to make all the cookies at one time. So the 1/4 could kind of be like maybe just the that he used, right? He used that 1/4 of the mixture. The mixture being the 3 plus 5. So now we kind of think of rewriting our problem here. 1/4 times the sum of 3 plus 5. 8, because 3 plus 5 is 8. And so 1/4 times 8 is going to be equal to 8 over 4. And 8 over 4 is 8 divided by 4, which is going to equal 2. So since the unit of measure was all based on cups, our answer should be cups. So he used 2 cups of the mixture. Okay? Very, very challenging, I would say. If you did well on this and your word problem kind of connects to it. Okay, my friends. Woo-wee. Makes you want to go, woohoo! Yeah. That was a challenging video with some challenging problems. And I will do my very best to bring you a video very soon. But now that we hear the music in the background, live long and prosper, my friends.